So hello droidcon Kraków, thanks for being here. We are going to have a session about the Android permission system. And while this session is focused on the permission system as a global subject, we mainly cover MARSHMALLOW, but also LOLLIPOP, because MARSHMALLOW is kind of a LOLLIPOP is kind of a subset of MARSHMALLOW regarding the permissions.
Okay, so I'm Alizée Penel. I'm a system developer on the Linux and Android, and I'm working on the Genymobile emulator that I think you well know it already.
So I'm Alexis Rosovsky. I am an Android platform developer working at Genymobile, but I work on Genymaster, and Genymaster is the ROM customization solution for our customers. It's a cool project.
So, first of all, we're going to start with an overview of the Android permission in the perspective of users and developer point of view, and then we have to talk about the prerequisites of the Linux permission system. Then we can talk about Android, and we'll show you how it works in the system in order to understand how you can use it in the application lifetime. And by the end, we're going to show you small tips for your application.
Okay, so about the app developer perspective. So, you already know a permission is defined as a string. Permissions are part of the Android platform security. And another main point of the platform security is the sandboxing of application. Each apps get a dedicated process. Now, as a user first on LOLLIPOP, the permission presented in themselves in UI through this kind of pop-up. You can clearly see this is a Google Play dialog box. The permissions are grouped, and this UI does not come from the system. On MARSHMALLOW, the behavior depends on the target SDK from the applications. So when the target SDK matches MARSHMALLOW, here's an example with the write external storage permission, which is a dangerous one. So we get prompted by the UI, which clearly comes from the system. We don't get details about the permission, but only about the group the permission belongs. When the target SDK is lower than MARSHMALLOW's, we get prompted at install time. Permissions are still grouped. We can see the icon kind of group the read and write permissions. And I get both permissions, even if I only requested the write one, the write external storage permissions. And the UI comes from the system. Sorry.
So, regarding the permission, right? In all application, you are allowed to declare a group of permission. So how's the way you can do it? What is important here is that the only optional attribute is the Android priority. In the documentation in the system, it should be used in the system, but for the moment we don't find any piece of code using this attribute. So for the moment you can just leave it. What is important here is to give it, of course, the name and also the description of your group, that to make your permission consistent according to your label. And of course, a group is a set of permission, of course. So, I think you already know how to declare your own permission in your Android manifest. So, what's important here is that to declare, if you want to put your permission in permission group, is to fill this attribute, right? And if you don't give the protection level, it will be set up by default to normal. Okay, and to use a permission, you already know that you need to use a specific Android manifest tag is use permission SDK 23. That's the basic to use the permission in your applications. So, as you already know, there's different level of permission protection level for your permission. It's normal, dangerous, and signature. Signature permission requests to have the signature of your platform. And the other thing that's interesting is that you can apply some flag to this permission with this protection level that gives you access to some features if you're in development or privilege. It gives you more access to the system. But what is very important, is that in the system, in all the framework of Android, only the dangerous permissions are in permission groups. And what's important in Marshmallow is that all the permissions with a protection level dangerous are prompted, granted at the runtime. The rest of the permissions are granted on the install time, like in Lollipop.
Now about the application sandboxing. On a regular computer, we can assimilate one human to one user on this computer, which means one session. On Linux, these users are implemented through the numeric ID called UID for unique identifier, and there's a string representation that exists for readability convenience. Android is based on Linux, and each app gets its own UID due to the application sandboxing. We can see here an extract of PS, actually listing, process listing. The most interesting thing here is you can see the name, the processes are named according to their application package name, so we can easily identify them. And the UID is the column on the left. You can see the U0, A8, U0, A27 and such. Those are the string representation of the UID that actually backs the user associated to the application, the Linux user. The human user in this representation is only represented by the U0. So in a multi-user Android system, you would have several stuff there, U0, U1, U2.
Okay, so let's talk about the prerequisites. Okay, so under Linux you have UID and GID. A UID defines a user and you have a specific user on the Linux, they call root, a super user, and is identified with a numerical ID 0. The other user will start at 100 and other is a standard in Linux. All the process and files are strongly attached to the user. And the user cannot exist like that. It needs to belong to at least one group. Also, a group is identified by a numerical ID, is a GID, and a group may contain at least no user as many, but the user at least need to belongs to one group. Okay, let's see what's going on with the groups and the users. It gives you access to have rights on process and files. So the rights are read, write, and execution right, and you have here all the letters that represent your access to a file. So as you see here, Resolve belongs to the users group, and all the users belong to the group's users will be able to execute and read in this Lollipop directory. Is how it works. And you have three identities on the Linux: is the user and its rights associated, the group with the three letters associated, and the rest of the world can have access to the file, and is represented here, like here, the three last letters. Okay, what is a process on the Linux is a permission who have an execution permission. So when you launch a process, the process will have the same right as the user who launched the process. So if you can see here that the users are resolved start the process like systemd, and so that means that systemd has exactly the same right on the file system as the user.
Okay, so now how this information is used in Android. I'm going to be pretty fast-paced on this because we used to make this presentation in 45 minutes and we have a bit less here. So it's very close to what happens on Linux. UID0 is still the super user. We get the same kind of information. Well, GID is the same usage. One user can belong to several groups through the GIDs. Specifics to Android is UID 1000 is the system user defined by Android. UIDs greater than 10,000 are applications user, specific to Android too. We can see in this specific file the data system packages list, which contains a few information about the installed application, that an application is described by its package name, first item on the list there. Then we get the UID for the app, 10,000 something there, 1,001 there, and the GIDs, group informations. So that would be the group which the user belongs. We can see here that Android uses specific user and defines specific user for different features. basically one user per feature. The AID radio means Android ID radio, used for telephony stuff. It's the 1001. The package name we saw earlier was Com Android phone, so kind of matches up. Telephony subsystem is used, rely on this specific user. The file permission are applied the same way, so this is the files specific to the calendar application. You can see there is the user information there, group information, which is the same by default because the default GID is the UID. Sorry. And you can do a little bit of testing when developing an application when you use the ADB shell run as command. Run as with a package name as argument allows you to switch UID to the application ID. Because you have to know that when using ADB shell without anything special, you get the AID shell, which is one of the specific IDs defined by the system. So to look like an application still using shell, you can use this. Another application specific to Android would be the directories of the system that the platform sets and configure with the specific rights. This is located in a C configuration file. The location depends on the Android version. We can see that for the cache directory located at the root of the file system, we get the UID system there, the group, the GID cache, and those would be the access rights, only represented in octal form. So this is the equivalent to the RWX information for the three groups, user, group, and others. This is what we can see here is on a device, we can see this is a directory. We can see we get all permissions for the user, all permissions for group, nothing for others. The user is indeed the system user. The group is indeed the cache group for the cache directory. As an application developer, one of the few ways you can interact with this information is the shared UID attribute of the manifest tag. By specifying a shared user ID, you can, share this UID between several packages. This is a way to share permissions between packages. Regarding runtime permissions, since permissions now have a state, granted or not granted, this permission state is propagated upon all packages using the shared UID, the same shared UID. And on top of sharing UID, you can also share a process between several applications, or actually between several packages.
Okay, so let's talk about the permission lifetime. So you know that when you are sending an apps, it will be, so now PK is going to be the package manager who's going to parse your Android manifest XML. And he retrieves some information from your XML regarding your permission, and we store this permission in two different files. Will be package list and package XML. The rest of the process is delegated to install D. So it's a very simple way how apps are installed in Android. Okay, so what happened at install time regarding the permission is that normal permission are granted. And if you have signature, you have application with a signature of the platform, so signature permission will be also granted at this time. And regarding the application using an AP layer under the MARSHMALLOW version, all the permission will be granted at install time. But what's important here to remember, as we talked about multi-user, the permission will be granted at the install time, but true for all the users of the device, so U0, U1, and everything. So we need to talk about the process, how the application starts on Android. When application starts, the Zygot is triggered, and what happened is that Zygot is a native daemon with a preload framework library with a framework library preloaded, sorry, and then Zygot is fork, but Zygot is a native daemon, so Zygot will run as root. So when your application is launched, at the beginning, the application has the root rights, but it's actually what we don't want to do. So we're going to do system calls to change the right of the application. Then at the end, when we be fully launched and access will be available for the user, the application will have the own user and user ID and GID. Specific to, yeah, of course. So, what we don't say right now is, remember at the beginning of the talk, we show you a line with GIDs at the end. The other way under Linux to access some privilege is to add a user to another group, and this group have more privilege than the original one. So you can add your user to many groups. And what we call that in Android is GID mapping. So for example, I think for the internet connection, it was like not for internet connection, it was for the writing internet connection permission. Not internet can become normal, I think. It's not it's normal. It's a GID mapping, yes, that's right. So what happened is that your system needs to know which GID to apply to the different application using this given permission. So at the boot time, what happened is that your package manager service is going to parse the permission platform XML file containing the GID mapping. Okay, for this permission, I have this GID, and this GID gave me access to this feature. So when it's booting, it gets the information there. And when you're installing your application regarding using Google Apps or Google Play or IDB, what's happened is say, okay, I'm going to parse the APK, the Android manifest in the APK. Okay, I know what permission is used in the application. I know that this permission is using the GID, but how you need to link everything together. And then what happened? Because when you're starting an application, the activity manager is launched, and then is the activity manager is going to call the God to start your application, and because your package manager have all the information, is the activity manager who's going to retrieve the GIDs and then be able to apply to your process, your new process of your application. That's how you get privileged features in your application.
For the permission, yeah, GID mapping related.
Yeah.
Okay, so what happens at runtime? So basically at runtime we get a grant for dangerous permission groups, or permission groups that hold dangerous permission. Those permissions are revocable. Those are unique per user, so on a multi-user system, runtime permissions gets granted only for the user that got actually granted. That has been granted. And revocation kills kitten, well, it's just when you revoke a runtime permission, all related packages get killed. So you kind of have to know that. It is very transparent to the user, actually, because it still holds in the application information in the recent tasks, but the process, the underlying process related to this application gets killed and relaunched appropriately. So this is quite a long GIF that's going to appear on the right side of the screen. Let's hope I get it from the start. This is the right external storage example. This is the end, obviously. Okay, so the point is, let's have a look at what happens when you revoke permissions. Now it should begin. So I click on the button, I get prompted. I can deny or allow. Let's deny. Now, I can't write on the external storage, and if I click it again, I get prompted again with the never ask again box, checkbox. Checking this box prevents me to allow the permissions. So I check the box and then deny it again. If I press again write external storage, I don't get prompted and I can't write on the external storage. My only way out of this is to getting back to the application specific settings and then re-enable the permissions just as you saw in those slides, in this animation. So that kind of means the system knows when the user gets prompted for the permission and has a persistence about this, because checking the box will change the behavior, the future behavior. So how does this work? Well, when my sample application requests the external storage directory, so some kind of feature, some kind of method that requires this permission, we end up in the mount service, which checks policies. In this very specific location in the code, policies is just an abstract way of checking permissions. A little bit more than that. And this policies says, okay, package manager service, does the app that called me has the permission in its manifest? So that's one thing. And then to the app service, did the user actually grant the permission at runtime that I requested? If both, if those two conditions are matched, then the mount service is going to provide information to the user application. The persistence information is handled by the app service in the data system app XML files. So we can have a look at the current state of all the permissions system-wide per user in this file. So what did we just see? At install time, that concerns permissions granted at install time, normal permissions and signature permissions. So basically system packages and normal permissions such as the internet one. Those are granted for all human users, all sessions. And applications used by several human users will get all the same permission states regarding these kind of permissions. This is handled by the package manager service, and the information is written down in the data system packages XML file. For runtime permissions, this is only concerning dangerous permissions. This is a per user, as in per human user basis. The persistence is handled by the app service, and the app XML file handle this. Actually, I think I just forgot something. On this schematics, one thing is missing. Everything UI related is not included in this schematics. Everything UI related for permissions, the actual grant, the installation activity you saw earlier, it's actually in the package installer application, which is part of the platform. And there's an intent exchange happening between the package manager service and this specific application that, of course, has a specific right to be able to do this. But since this is about granting permission, I didn't really need the UI information in the schematics. Okay, so we found out in the settings application that you can obviously list all permission used by a specific application. You can also do the same thing the other way around. You can list the permissions of the system and per permission check which application is using it. So this is the advanced settings, going through apps, then the settings wheel, and then the app the app permissions, sorry, just had it out. So we can access this information both ways. We can also see in this animation there are special permissions. In the next screen we can see there's a permission related to system settings and another one related to draw over other apps. So that would be overlaying UI. Those permissions are a bit special, and if you need them, you can't actually request a runtime grant. You have to lead your user through the settings applications to enable those special permissions for your applications. This is due to actually a flag called AppOps in the permission declaration. This flag is only available for permission declared within the platform or for signature packages. Now, this is a little problematic that actually everybody knows because we used it on a regular basis. The fact that you can name an activity, for example, only with a .activity name or just activity name, because we know it is going to get prefixed by the package name. But a permission is also a component of an application, but not at the same level. So I was actually quite surprised to realize the declaration of a permission group is subject to the same kind of logic. So the three declarations we got there for a group are actually perfectly equivalent. But we have to understand that the system is going to record the group using this name. Therefore, whatever the way you choose to declare your permission group, when you are going to refer to reference this group in the declaration of your permission, you gotta get the full name, the full prefix name.
Okay, what happened when you have a headless application? Sometimes it's happened, but now we have a new permission system at the runtime, and the runtime asks you for a UI. So the only way you can do it, two ways to do it, is using the ShareUID attribute in your application. That the other application had the good permission granted, then your headless application will have the right and the access to your features. If you do not have any, you're not able to use this attribute, what you can do is to show up to your user, even if you're in a headless application, the settings of your application directly. Then the user will be able to grant the things. But the only way that you can do that with headless applications. The other things that you can help developers, if you have any problem regarding your UID, the change of your UID and everything, you have a log in data system UID errors that give you a lot of information about that. So what we can say about the new permission system given by Google and Marshmallow is that we can see that Google tried to make people sensible to security matters, also to the user, but at the end also to the developers. You need to use the new API given for the permission to check if you have the permission and call it to be sure to get your prompts for the runtime. But the way Google did it, you're not prompt each time you request your feature. Because of the persistence, it avoids the user fatigue in your application. But what you also need to do is to justify the need of the feature. Then your user will understand what he's doing in your application and what happened also, and he deny it. And you need to support the permission denial, and your application must not crash. If the user refuses to give you the permission, you need to inform your user, say, okay, you said no, so I can give you access to this feature. That's your role, that's your job, if I can say. So thank you for your attention.